Welcome back to Tracing the Sky. So in the last video, we focused our attention on a single star, and we traced its path over the course of a single night. We saw that, like the sun, it was moving from east to west, and that its path was an arc. We also observed the next night the star had come back around to where it started. And the question I left you with was, how are the rest of the stars moving? Are they moving in a similar way? And is there a way for us to figure out if there's a general rule without having to observe and track every single star in the night sky? So that's what we'll tackle today. Now, if you were to go observe the stars over the course of many nights, something interesting would probably start to stand out. You would probably start to notice groups of really bright stars that always seem to be together, that seem to make shapes. And once you saw these, every night you went outside, you'd be able to spot them more and more easily. So let's have a look at a few of them and see if they can help us understand how the stars move. Well, here we are facing north, and there is one group of stars that my eyes can't help but look for every time I go outside. And I wonder if you do the same. For me, it's the Big Dipper here, and I'll draw it for us. So if I connect the dots of those stars, we get the Big Dipper. And you might be thinking to yourself, oh yeah, I've seen that before. It's a constellation, right? Well, the Big Dipper on its own isn't a constellation, but it is part of a very well-known one. If we connect a few more dots, we get Ursa Major. And Ursa Major stands for the Big Bear. And you can kind of see that, right? This kind of looks like an animal. And so the Big Bear, Ursa Major, comes to us from the Greek and Roman traditions, but many different cultures identified this constellation and had different names and different legends and stories for it. And that's something very common to many different ancient peoples, is they would look up at the sky, find these groups of stars, draw these patterns, and attach stories and names to them. And these are what we call constellations, and there are a lot of them. Okay, so here I am facing south, and I've gone ahead and drawn a few constellations for us. We've got Aries in the bottom left, we've got Lyra up top, and we've got Libra in the bottom right. And what we can do next is jump ourselves forward in time and track the movement of these constellations. And that's something you can do too. If you want to pause the video, in the description you'll find a link that will allow you to track this for yourself. And then you can come back and compare to what I'm doing. Okay, let's give this a try together. So I'm going to jump us forward in time, and we're going to keep a close eye on the constellations to see how they're moving. So let me jump us forward. We'll start 10 minutes and then another 10 minutes and try and notice how they moved. And let me trace it for us too. Okay, well, this is starting to feel a little familiar, and a few things jump right out at me. All of the constellations moved from east to west, right? And that's similar behavior to what we saw with the sun and the other star. The motion was always east to west. But we can notice a few interesting differences. Aries, which is further east, moved up a little bit too, and to the west. Lyra didn't change height. Maybe it went a tiny bit up, but it seems to be, level or close to it. And Libra definitely is setting, right? It's going down and starting to dip below the horizon. So let's jump forward 20 minutes more and see if we can notice any of these patterns continue. Okay, well, I think we're definitely starting to see a pattern, and I think we can start to add some color to our descriptions. I think the first thing that's the most obvious that stands out, and one of the primary motions, is this east to west motion. All of the stars are going from east to west. The sun is going from east to west. And that star we looked at last time was going east to west. So that seems to be an important primary kind of motion. But we can also notice a few other things. The star we looked at last time, I don't know if you remember, but when it was east, it was rising, right? So when it was further east in the sky, as it was traveling west, it was also rising in the sky. And we can see that here with Aries too. Aries, which is our eastern constellation here, it's rising as it goes west. Lyra, which is, a little closer to the middle, is starting to level off and start to actually turn on that curve and starting to set, versus Libra, which is further west already, well, it's definitely setting. And so we can notice these two kind of primary motions, right? This east-west motion and this arc where it rises when it's in the east and then it starts to set into the west. And if you were to continue going and moving yourself forward in time, you would notice that these constellations follow that progression. Aries is going to continue to rise in the sky, Lyra is going to start to set, and Libra pretty soon is not even going to be visible. It's going to dip below the horizon. Okay, there's one more really important thing I want you to notice about the constellations. If you look at how far each constellation moved, right? If you look at the distance between, the red and the green and the yellow, and you look at that for each of the constellations here, it looks like the distance is about the same. So each constellation moved by the same amount every 20 minutes. And notice that all of the stars in that constellation move together, right? It's not like one star is wandering off in a different direction. And that kind of makes sense, right? If the stars in the constellation weren't always grouped together or moving together, we probably wouldn't notice them. They wouldn't stand out because they wouldn't be together always. But here we can see that each constellation moved the same distance, and that relative to the other constellations, they also moved the same. So the way to kind of think about this and the way it looks is as if you've got this sky here, and each constellation is pinned to the sky, and it's not the constellation that moved, but it's as if we moved this entire sky forward the same amount, and each constellation moved with it. Now, if you continued to make observations like these and chose different constellation, different stars, you would see that they're all moving in the exact same way that we've just observed. They're all going from east to west, they're rising in the east, they're setting in the west, and they're traveling in an arc. And just to hammer this home, let me do a little time lapse with you so you can see that all of the stars appear to be moving as one. In fact, it'll kind of look like the Earth is surrounded by this giant black sphere that's studded with stars, and that the entire thing is moving as a single unit, and that sphere is moving all of the stars. So have a look. As we jump forward 10 minutes at a time, notice that all of these stars are moving together. If you keep your eye on any two stars, they're not getting further apart or closer together. It's like the entire sky is moving from east to west, that stars in the east are rising, stars in the west are setting, and that stars are traveling in this arc. Okay, so by observing a few groups of stars, we were able to better understand how all of the stars are moving. We can see that it appears that all the stars move as one. They go from east to west, and they rise and they set. And in fact, it looks a whole lot like the Earth is surrounded by this giant black sphere studded with stars. And that it's that sphere that's turning, dragging these stars across our sky. Now I'll leave you with one mystery that we'll pick up on in the next video. If you were to go out on any given night, whether it's January or September or May, would the sky appear the exact same? If you were facing south, looking up, or north, what would be the same, what would be different? We'll answer that in the next video. See you next time.